I would like to discuss a historical experiment that's very important, and it demonstrated that charge is quantized. Okay, and what I mean by quantized is that it comes in little packets of a certain size. You can't have any arbitrary amount of charge. You can only have units of that amount. Okay, so the experiment itself is actually pretty straightforward to understand, apart from some details. Okay, so what Millikan did in this experiment is he took essentially just a squirt bottle that had some oil in it, and the squirt bottle created little charged droplets of oil. Okay. And that just happens on its own because in the process of being made into these tiny droplets, some of the charge gets left behind. So either these are positively or negatively charged droplets. Doesn't really matter for understanding the experiment. Okay, so with these really small droplets, what you can do is create an electric field in some external way, and I'm going to draw it this way. So let's say that we have some negative charge over here, and then we have some positive charge over here. And then you're going to get an electric field that points upwards like this. Okay, and I'll sketch it as approximately constant. Okay. And then if you have some of these charged droplets inside this electric field, then what happens is you'll get a gravitational force on the droplet. So gravitational force on the droplet by the Earth, and you're going to have an electric force on the droplet by the field. Okay. So by adjusting the electric field, you can get those into equilibrium and figure out what electric force you have on that particle. All right, so this is the general idea, and by doing this, since you know that the force is that electric field times the charge, you can figure out what all the charges are from this. Now, a detail of the experiment that you can read about in the textbook if you're interested, but I'm not going to go into a lot of work with, is that the air resistance is actually kind of important and actually helpful in doing this experiment. So we can include some air drag, so drag on the droplet by the air, and that also comes into play. But for the purposes of understanding the experiment, all you really need is that we can tell what that charge is from doing this. And what you find is that if you do this experiment over and over, and you take a bunch of different drops that all have random amounts of charge, and you measure what the charge is through doing this calculation, then what you get from your analysis is that plotting out the charge as a function, or just number of particles with a certain amount of charge, you get these little peaks. Okay, only certain amounts of charge appear to be possible. You don't have just any amount. You've got multiples of some basic amount. So this is 1 electron's worth of charge. And this one is 2 electrons, and this is 3 electrons, and this is 4 electrons. But you never have half an electron. You never have 0.7 electrons. It's always some integer multiple. And this is actually a pretty difficult experiment to do because you have to know, or you have to know the uncertainties are small enough that this won't all get blurred out, and you have to be able to measure forces on 1 or 2 or 7 electrons. If you started to have hundreds of electrons per droplet, it would be almost impossible to be able to notice if it was quantized or not. Okay. But this was the experiment that showed that charge comes in discrete units.